Alright guys, so this is topic 4, very similar to a topic that we did in chapter 1. This is not arithmetic sequences, it's actually arithmetic sequences is how that's pronounced. So basically we're going to talk about a sequence of numbers where the numbers change by the same amount each time. So an arithmetic sequence has a common difference, or I like to refer to it as a common change. So what that means is you get the next number or the next term. So each of these are terms. So this is like the first term, second term. So if I say what's the fifth term, this is the fifth term, it's 11. You get the next one by adding or subtracting the same number to the one before. So here we add 2 to get a 5. To get the next number, we add 2. To get the next number, we add 2. Alright, so as long as there's a pattern where you're adding or subtracting the same number, you have an arithmetic sequence. So here we have to minus 4. Here it's minus 4. And each change is minus 4. So it's an arithmetic sequence, or an arithmetic sequence. So determine whether they are. You just got to simply see, is there a common change or a common difference each time? So how do I get from negative 4 to negative 2? I can plus 2. Here I plus 2, here I plus 2. So yes. So the next 3 terms, so first, second, third, fourth, the 5th, 6th, and 7th terms would be a 4, 6, and 8. They just continue the pattern. Here there's kind of a pattern going, but it's not arithmetic. Right? You have to add 3, then you're adding 5, then you're adding 16. So that is not an arithmetic sequence. So here is your first U try. There will be several U tries. Alright, now looking at sequences and tables, very similar. This is going to be like writing the rule, only now we're relating it to linear equations. But it's going to be similar to writing the rule like we did with functions in the first unit. So you could read this, but basically what it's saying is we let x stand for what term it is. So this is which term. So first, second, third, whatever. And then this is what it's worth. So the first term is 2. The second term is 5. The fourth term is worth 11. So it's arithmetic because it's going up by plus 3 each time. So the next 3 terms would be 14, 17, 20. And the 0 term. So for the 0 term, all you got to do is continue the pattern backwards. And I don't know why the writing is weird, but I'm going to go with it. Hopefully it works. So continuing the pattern backwards, we get back to 0. So if I continue this pattern backwards, what would I have to add 3 to get 2? Well, this would have to be a negative 1, because negative 1 plus 3 is 2. So you're just following the pattern backwards. So the 0 term here is a negative 1. If you know the common difference in the 0 term, you can write the equation. That's all you got to do. So if we want to write the equation for this, it'd be y equals 3x, common difference or common change. Remember, this is our slope now, so slope is rate of change. That's why I like common change instead of common difference. And then minus 1 or plus a negative 1. That is our function. So that tells you if you plug in x, that would be which term you want, like 7th term, 8th term, 500th term. And then this is going to be what it's worth. So this is which term, and this is what it's worth. Alright, so let's do this a couple times here. We got to find, first it's got to be a common difference. Is there? Yeah, we minus 2, minus 2, minus 2. Okay, so it's the same change each time, so it's an arithmetic sequence. Alright, now we continue the pattern backwards for the 0 term, because we want y equals the common difference or common change times x plus the 0 term. So the 0 term, if we continue the pattern backwards, this would have to be a 3, because 3 minus 2 would give us the 1. So that tells us it's y equals the common difference, -2 times x plus 3. Alright, so let's do one more example here. Here, this is going up by 4s. So notice if it's going down, you have to have the negative here. If it's going up, you have to, if you're adding a number every time, then you have a positive rate of change or a positive slope. So continuing the pattern backwards, what would you have to add 4 to? It'd have to be a -1. -1 plus 4 will give us the 3. So we have y equals the common change, which is 4, x plus -1. There we go. So same exact idea, do it with these last couple problems. Alright, and then there's just a little more. So here's our second U try, and then there will be a third one after this next slide. So if you're really paying attention and watching this video, to prove it in class, I'm going to check and see if you wrote this little symbol here. No, there it is. I want this little symbol in the right hand corner of this slide, and I'll be checking for that next class. Okay. Alright, so let's apply the knowledge of sequences to writing equations. So if Kristen deposited $200 into a savings account, each week thereafter she deposits $15 more per week into the account, let's write a function rule to give you the total amount she's deposited on any particular number. So basically we want to write the function rule. On week 0 at the very beginning, she had $200. That's what she put in. 1 week later, she has $215. 2 weeks later, she has $230. Alright, so our common change is plus 15, right? She's adding $15 per week. So on the first week, she's got $15 more. Our 0 term is going to be $200 because that's what she had at the very beginning before 1 week had elapsed. So we have y equals 15x plus 200. And then every time you do, I forgot to say, every time you do one of these, you want to make sure that you test it. Okay? So let's make sure I did the right rule. Let's pick let's pick this one. X is 3, y is 11. Plug it in and see. If x is 3, we have 4 times 3 plus -1. That's 12 plus -1 is 11. So that's what it should be. Alright? If you're having any trouble with these, test them and that'll tell you whether you've done it right or not. So that's key. Alright, I forgot to tell you that when I first went through those. So now how much has Kristen deposited 5 weeks after her initial deposit? So if we want to look for the 5th week term, it'd be y equals 15 times 5 plus 200. Alright, so 15 times 5 is 75 plus 200 gives us 275. Now if she wants to buy a $499 iPad, how many weeks? So in this case we know how much we want to end up with. We know what the value is worth. We want to know which term, or aka how many weeks until she obtains that. So we're going to set it $499 for y equals 15 times x plus 200 and solve for that. So we've got $299 equals 15x, divide by 15, divide by 15. So we get 19.9 equals x. So that means at 19 weeks she won't quite have it. By the 20th week she'll have enough money. Actually a little bit more. Alright, so that would be the answer there. So your last U try is going to be this one. Alright, so very similar. Get your sequence, write your rule, use your rule to figure some stuff out. Alright, see you next class.